In this lab, you'll use distillation to separate your unknown from an impurity. For this lab, you'll need to set up a simple distillation system. You'll need a long neck, round bottom flask, a distillation head, a component part connector, a thermometer, glass wool, tin foil, as well as an Erlenheimer flask and ring stand and clamp. Start by assembling the distillation head to the support rod and the long neck, round bottom flask to the support rod too. Position the bottom of the round bottom flask just above the hot plate and secure it to the ring stand with the clamp. Position your Erlenheimer flask or collection flask just below the spout coming from the component part connector. They do not have to be touching. Using a rubber adapter, carefully insert the glass thermometer into the top of the distillation apparatus. The thermometer's tip should be about where the branching occurs. Angle the distillation apparatus slightly downwards to help encourage the condensate to fall into the collection flask. First, weigh your sample in the vial and record this value, then place your sample in the round bottom flask. Then reweigh the vial. The difference between the masses is the mass of your sample used. You can then reconnect the loaded round bottom flask to the apparatus using the rubber fittings. Once your sample is loaded and the round bottom is securely placed in the heating mantle, loosely pack glass wool around the top of the flask and secure with tin foil. Be sure that no tinfoil is underneath the flask. Double check your setup with your instructor or TA before continuing. Now that you are all set up, plug in your hot plate. Then turn on the heat and set it to your desired temperature. 70 degrees Celsius is the lowest boiling point of the possible unknowns, so this would be a good temperature to start at. Gradually increase the temperature until condensation begins to appear. Take note of the temperature at which this begins. Once you have collected your sample, transfer it to a pre-weighed vial, then reweigh it to determine the amount of sample collected. You will then prepare a GC sample, get an IR spectrum, and a carbon NMR.